Science is important to the design thinking process, a highly regarded methodology used in design, engineering, and business fields to promote innovation is known as design thinking. As shown here, design thinking consists of 7 interrelated phases. The first 3, understand, explore, and define, involve developing a deep understanding of the factors that impact a design. Included at the top of the list are the vast bodies of scientific concepts that govern the natural world. For example, it would not be possible for engineers and designers to design pickups for electric guitars without a firm understanding of concepts relating to magnetism, such as magnetic induction. As we demonstrate in the technical videos, you'll see how Autodesk 3ds Max can help anyone, regardless of their prior artistic or technical background, engage in the process of ideation. These same tools will enable you to take this or other projects of your choice through the remaining stages of design thinking that include prototyping, refinement, and the presentation of final solutions. We present the following overview of atoms, molecules, and gases to aid in the understanding and exploration phases of the design thinking process. The Rutherford-Bohr model is an atomic model used in the technical videos, and it's a simple atomic model. It's useful for explaining some of the basic principles of an atom without getting into more complex topics. However, it's inaccurate in many regards. The importance of this model is that the majority of the mass of the atom is concentrated in its very small nucleus in the center. The electron cloud exists outside of the atom, and the electron cloud makes up the majority of the volume of an atom, while the nucleus makes up the majority of the mass. Covalent bonding is the sharing of valence, or outermost electrons, to complete a shell. Every time an atom shares one of its electrons, the other atom it's sharing with shares one of its electrons. As opposed to ionic bonding, where one atom takes the electron of another, a complete valence shell for oxygen requires 8 electrons, but normally it only has 6. When 2 hydrogen atoms share their electrons, 6 plus 2 equals 8, making it a stable molecule. Consequently, hydrogen only needs 2 electrons to fill up its valence shell, so by sharing one with oxygen, oxygen shares one with it, completing its shell of 2. The same can happen with oxygen to make O2, but with a double bond where 4 electrons are shared. Because water is bent and the hydrogen atoms are slightly positively charged, water molecules are polar. This gives water many unique properties, such as its relatively high boiling point. Its polarity allows it to dissolve ionic compounds and keeps it from mixing with nonpolar liquids such as oil. It's common for water to exist in a gaseous phase, such as humidity in the air, or as steam from a boiling liquid. Ideal gases are gases that are composed of randomly moving particles that do not interact with each other. Many gases act as ideal gases at standard temperature and pressure. By assuming a gas acts ideally, it's possible to use the ideal gas law, PV equals nRT. Pressure times volume equals the number of molecules of the gas times the gas constant times temperature. This is an extremely useful equation and is often used for designs involving gases, such as hot air balloons, power generation using steam, air tank design, pneumatics such as cylinders, and much more. The following technical videos will instruct you how it's possible to create simple but effective Rutherford-Bohr models of atoms and how to arrange them into molecules. Furthermore, it'll show you how it's possible to create realistic simulations of ideal gases. These models not only help you during the understand, exploration, and solution stages of design thinking, but can be practically used as simulations to develop designs and theories using atomic models during the ideation and prototyping stages.